Hello all, welcome back to Aislyn Technologies YouTube channel. Today we're gonna see about development of image processing algorithm for estimation of water volume based on external image features of tender coconut. Here is abstract. I'll explain the abstract first. Our abstract is coconut water is a nutritious and hydrating beverage that is low in calories and fat and rich in minerals and vitamins. The increasing global demand for tender coconut water highlight the importance of preservation and processing method to ensure year-round availability. Our project focuses on developing an image processing algorithm to estimate the volume of water in tender coconut based on external visual features. This technology aims to assist farmers in making informed decisions regarding price and sales. Here's the problem statement. Our problem statement is about a coconut family is a highly profitable cash crop, providing sustainable returns for farmers. However, without reliable method to estimate the volume of coconut water, farmers are often unable to sell their product at the competitive retail price. This lack of information leads to reduced profits and limits the farmers' availability to capitalize on their investment. Our objective of this project is distinguish between tender and non-tender coconuts using image processing technique and estimate the volume of coconut water based on the shape and size of coconut as identified through objects. And then enabling farmers to determine the volume of coconut accurately, allowing them to sell their products, allowing them to sell their produce at optimal price and thereby increasing their profits. Our existing system, I'll explain you. Currently, the systems primarily rely on traditional farming practice without leveraging technology for volume estimation. The farmers often lack the tools or knowledge to measure the volume of coconut water accurately and resulting in suboptimal pricing. This leads to a scenario where farmers are unable to maximize the profit as they cannot sell their tender coconut at the fair market rates. These challenges faced by existing systems underscore the need for innovative solution that can assist farmers in estimating coconut water volume and improve their profitability in the market. Our project addresses these issues by implementing the technology-driven approach to facilitate better decision and making for farmers. Now I'll explain you our proposed systems workflow. First of all, you collect our sample image of coconut and we are doing image acquisition. It's nothing but we'll take our data set from another source, what image of plus, and then we are doing extraction of those images. Based on those images, we'll extract the features, and these features are given to our model. And then based on our model and the metrics, it will be evaluated the volume of measurements of particular coconut. So it will be printed here. Now, now I'll show you a training code. Yeah, this is our training code. Yeah. Today we have four targets in our data set. I'll show you our data set. This is what our data set looks like. Flat, horizontal, no tender, straight. So this here our target is four, and our path is coconut. It's nothing but our data set name is called coconut. And here your data set will be divided into train files and train targets. And here you will be get a statistical values of your data set. That is total categories, total images, training images, and testing images. Here, what you will have done is you will turn your 3D images to 4D tensors to feed into your model. So that you are doing here. Here it will show the total timing of one epoch as to run. That's what we are defined here. Last epoch timer. And finally, you will be, and these are the hyperparameters that will be given to a model. The batch size is 32, and the first filter is 32, and the 64 filters will be applied in the model. This is what your model. and then these are the layers will be added to your model, and then your model will be fitted into your path, your data set. The train tensors and train targets your data set that will be converted here. You to feed into a model, so then converting here. So that only will be given here. So after doing, your model will be saved as trained model DNA. Uh, Now I'll show you a testing code. Yeah, here's our testing code. Before that, I'll show you our features. That is yeah, these are the features what we have. So these are the features that will be calculated in backend. So that's what we're doing here, and we are importing this file. So here, that's what we're doing here. Now I'll run this. You can see this our model is imported here. Now I'll run this. It will show the features and everything based on the coconut. I'll run this. You should select any image. So I'll select front. Okay, I'm selecting any one of the image here. Select the second image. Yeah, you can see this is original image, and this is the masked image that we have got. This is the masked image, and this is our object segmentation image. It will be segmented separately. And this is the volume of the image. And here you can see the given component is tender and coconut contain these message of water. This, yeah. Thank you for watching Aislyn Technologies YouTube channel. If you have any doubt on this project, you can comment below. And don't forget to like, share, and subscribe. Thank you.